This video is on the objective make a conclusion and interpret the results of a one-mean hypothesis test. And this is with the population standard deviation unknown, right? Sigma is unknown, so this will be a t-test. And this is going to be using the p-value approach, right, as opposed to the critical value or rejection region approach. And this is number 1. So the first video on a question related to this objective from your Newton Alta homework. So let's take a look. So again, if you're unfamiliar with the topic, want to see more about it, please click on more instruction and look at their notes, their videos, their examples, and hopefully those help you out. So here the question is, Rebecca is a real estate agent who would like to find evidence supporting the claim that the population mean market value of houses in the neighborhood where she works is greater than $250,000. To test this claim, she randomly selects 35 houses in the neighborhood and finds that the sample mean market value is $259,860 with a sample standard deviation of $24,922. And the question is, should Rebecca reject or fail to reject the null hypothesis given the sample data below? Alright, so I'm going to write out, we're performing a hypothesis test about a population mean here, mu, right? And this time mu, the population mean, is the mean market value of all the houses in this neighborhood where she works. All right, so I'm going to start writing out some of this information on paper. So again, the claim that she's testing is that this mu, this mean market value of all the houses in her neighborhood, or the neighborhood where she works, is greater than $250,000. So remember the steps of hypothesis testing, right? Some claim about a population is identified, or some belief is identified. Then you form your hypotheses based on this claim, the null hypothesis, the alternative hypothesis. Now the claim here does not involve equality. So that's going to be represented by the alternative hypothesis, right? That the mean market value in this neighborhood, I'll just write 250,000 without the dollar sign. And then the null hypothesis always involved equals, right? Equality. And you could legitimately do this. Remember, the null hypothesis and alternative hypothesis, they have to be opposing statements, and the opposite of greater than would be less than or equal to. Alright, but and this is perfectly valid, but in this book, in this Newton Alta homework, in a lot of textbooks, what they'll write for the null hypothesis is just what's assumed to be true, so just the equal part. So what we're going to be assuming here that the population mean is equal to $250,000. Alright, and so this is going to be used as the null hypothesis. Alright, this will be H0 in most texts, and in this one as well. Additionally, remember, you can look at how the alternative hypothesis will, well, before I talk about what kind of tests we have, remember that right now the alternative hypothesis is where the claim is, right, is what is representing the claim. And then additionally, you can look at how the alternative hypothesis looks and know what kind of a test you're running, right-tailed, left-tailed, or two-tailed. And this is the parameter is greater than some value. So this is a right tailed test. And what we're doing here is, the p-value approach, or the p-value method for hypothesis testing. So when I'm doing a right-tailed test, remember the p-value is just the area to the right of the test statistic. All right, so before we get to the test statistic, though, let's talk about our significance level. Remember, after the hypotheses are formed, usually a significance level, called alpha, is identified. Now, in this particular question, a significance level is not mentioned. And if that's the case, it is 5%. All right, but usually if significance level is not mentioned, it's pretty reasonable in most cases to assume 5% significance. So 5%, or as a decimal, 0.05. Sorry about that. Scratch that out. Okay, and then we have our, take a sample from the population. They said the sample size here was, 35. She took 35 houses in this neighborhood and found the average market value of these 35 houses, and that would be the X bar, the sample mean. And this was $259,860. And the sample standard deviation was $24,922. And again, remember, the population standard deviation, right? Sigma is unknown. Now, if we assume that the population has a normal distribution, so assuming a normal population, or a normally or approximately normally distributed population, we can apply the central limit theorem here and say that, the distribution of means, right, sample means for samples of size 35, will be this student's t-distribution with so many degrees of freedom. Now remember, for these single population, one sample tests here, tests for means, the degrees of freedom was just the sample size minus 1. Right? So it was the distribution of means would be a student's t-distribution with 34 degrees of freedom. And the mean of the means is the mean of the population, which we are assuming to be $250,000. Standard deviation of these sample means, remember, normally it was the standard deviation of the population. It was sigma divided by the square root of n, but we don't know sigma, so we use s as an estimate, right? S over the square root of n. So this 24,922 divided by the square root of 35, right? And you can punch that in and approximate it, but I'll leave it for right now. Now what we're going to find here is our test statistic. Now again, I know they already gave it to us, but I'm just trying to show you where it came from. All right, we'll go back to the problem in a second. So after our sample's taken, when we have our sample mean, find our test statistic for that sample mean. Now remember, the test statistic in this case with sigma unknown, and we're doing a test for a mean, is a t-score, and it's a t-score is just like z-score, right? It's just how many standard deviations away from the middle are you from the mean. So I take my sample mean, right, $259,860, subtract the the actual mean of the population here, which was assumed from the null hypothesis to be $250,000. And then divided by the standard deviation of these sample means, which is this s over the square root of n, 24,922, divided by the square root of 35. So I'm going to pull up a calculator and punch this in, and you're going to see I'm going to get the same value they tell us back in the question. So again, you don't need to do this. I'm just showing you where it came from. Now the numerator is real simple, right? That's just $9,860. So I'm just going to put that in the numerator. And then in parentheses, this whole thing in the denominator here, I got 24,922 divided by the square root of 35. Okay, and you're seeing here 2.34 if I go to approximately 2 decimal places. So this is how they calculated this value here, right? Back on the website, back on the problem, you're seeing t is approximately 2.34 there. That's how they got that. And again, hopefully you remember seeing this even back when we were doing t-tests with the critical value approach. All right, but now we're doing, the p-value approach. Now this is a right-tailed test. Right, so going back to my paper here. So what we're looking at now is, here's the student's t-distribution. Right. Remember the horizontal axis is t-scores, and it's like a normal distribution, bell-shaped, symmetrical, with a t-score of 0 underneath the peak. And our t-score, right, our test statistic comes in at 2.34, positive 2.34. Right. So here's our test statistic. And then the p-value, right, because it is a right-tailed test, the p-value for this test statistic is just the area to the right. Right, area to the right of the test statistic is the p-value. Now you can find this on your calculator if you wish. So I go to second distributions, and you go down to number 6 here. Remember how normal CDF gave us area under a normal curve? Well, some of you hopefully have this TCDF, which will give us area under a student's T curve. So I go here, TCDF. What's the lower value in this region? It's my test statistic, and I'll just put the 2.34. Okay. What's the upper value in this region? Well, there is none. Right? This is all the way to the right forever. So I'm just going to put some large positive value like 5 nines. And then how many degrees of freedom? And I mentioned that earlier. The sample size was 35. This is a t distribution with 34 degrees of freedom. Right, and if you have an older one, you might have to enter it with the commas and stuff, where you put your left value, right value, and degrees of freedom separated by commas. And you see it's 0.012. Right, I'll round that to 0.013. So the p-value is approximately 0.013. And then remember what you do with the p-value to make decisions. And again, you saw the p-value approach when sigma was known, and you were using z-scores instead of t-scores. Well, this is no different. Even though sigma is unknown and we're doing t-scores, you still do the same stuff. You compare the p-value to alpha. Remember, I wrote this earlier. The significance level was 5%. How does this compare? Well, we're seeing that the p-value is less than or equal to alpha. Remember, if this is the case, right, 0.013 is less than or equal to 0.05, right? 1.3% is less than 5%. If this is the case, right, if the p-value is less than or equal to alpha, that means that the test statistic is too far from the center. If you were doing the critical value method, you'd be in the rejection region. So if the p-value is less than or equal to alpha, you reject the null hypothesis. All right. And if we're going to reject this, right, we're going to reject this statement, that means we are supporting this other statement, which was the claim. So based on this evidence, I'd say, the evidence supports the claim that the mean market value for these homes in her neighborhood is greater than $250,000. All right. So again, I just went through all the steps of hypothesis testing here. Now you're not asked to do all that. Again, you're just asked to, hey, they're telling you the test statistic. They're telling you, now they're not giving you the exact p-value, but they are telling you that the p-value is between 1% and 2.5%. Right? Remember, it was about 1.3% I found in the calculator. But they're telling you the p-value is between 1% and 2.5%. And that's definitely less than 5% then. So the p-value is less than or equal to alpha. And if that's the case, you're going to reject the null hypothesis. So it's this statement here. Reject the null hypothesis because, the p-value, which is between 1% and 2.5%, is less than the significance level of 5%. That's why you'd make the decision to reject the null hypothesis. Okay. And really, it's that simple. All right. I know I did a lot of work here. You didn't have to do all that work. All you had to do was say, hey, the p-value is going to be less than or equal to the significance level, so I'm going to reject the null. And if the p-value were greater than the significance level, then you wouldn't reject the null hypothesis. It's really that simple with this p-value method. And I believe that's all. I don't know if there's a second part to this. Nope. Okay, so real simple there. Hopefully, watching me do that, watching the more instruction stuff, reading their notes and videos and all that, hopefully that stuff helps you out when you're working on this kind of problem on your own. And thank you very much for watching.